Alright, what's up guys? In this video we're going to pick up some calculus here. It's going to be another integration practice video. It's going to evaluate the integral of the square root of 9 minus x squared all over x squared dx. So for an integral like this, I would use a trig substitution. And so in our case, we have the square root of 9 minus x squared. So in this case, this is just going to end up being a sign substitution. So this is going to be x is equal to a sine theta. A here will be 3. So we'll have x is equal to 3 sine theta. We then need dx, which would be the derivative of it, which would be 3 cosine theta d theta. So when we go to our integral, here's what we got. We got the square root of 9 minus 3 sine theta squared, and that's going to be all over 3 sine theta squared multiplied by 3 cosine theta d theta. And keep in mind, in my videos, I always write out all the steps. I don't skip steps. I don't skip simplification because I don't want anyone to get lost. So let's deal with the square root. So in this case, this becomes square root of 9 minus 9 sine squared theta. So in this case, this is square root of 9 times square root of 1 minus sine squared theta, which I know just gives me 3 times the square root of cosine squared theta, which simplifies down to 3 cosine theta after we've done all of the simplification with the square root. So now what we have is 3 cosine theta. Down here we're squaring the 3 and the sine, so this is technically 3 squared times sine squared theta. And don't forget, we were multiplying by 3 cosine theta. So essentially we can get rid of all these 3's, because if we cancel out a 3 down here, because remember, this is technically 2 3's down here, so one would cancel, and then we could cancel out the other one by cross canceling. So the 3's are all gone. Now we do have to multiply by cosine theta numerator, so we'll end up with cosine theta, or excuse me, cosine squared theta over sine squared theta, and then d theta. So this is where we're at after we do the simplification. Now we can use a trig identity for this, because remember that cosine theta over sine theta, that's cotangent, because we know that tangent theta, it's going to be sine over cosine, so that must mean the reciprocal of that, which is cotangent, would be cosine over sine. In this case, we got cosine squared theta over sine squared theta, so all that means is we can just end up writing this as cotangent squared theta d theta, and that's the integral we'll end up with at that point. We can then use a trig identity for that, more specifically a Pythagorean identity, and then I could just write this as the integral, and I can just write this as -1 plus cosine, or excuse me, cosecant squared theta, not cosine, excuse me, cosecant squared theta d theta. I can then just integrate that. So if I integrate this with respect to theta, I'll get minus theta. And this is going to be minus cotangent theta, and then plus c. So that's where you should be at with that. Then we go back to the substitutions at the beginning. Remember that x was equal to 3 sine theta. So if we solve for sine theta, we'll get sine theta is equal to x over 3. And if we solve for theta, we'll get theta is equal to arc sine, or sine to the negative first, of x over 3. Now, remember, when we use SOHCAHTOA, we know that tangent is opposite over adjacent, so that means that cotangent theta would just be the reciprocal, so it would be adjacent over opposite. Now we already know that sine theta is opposite over hypotenuse, So in our case, the opposite side would be x, and the hypotenuse would be 3. So the only side that we're actually missing is the adjacent side. So we'll need to find that, and we can use Pythagorean theorem to do that. So remember that a squared plus b squared is equal to c squared. And just to kind of catch you up as to where we are at, sine theta, that's opposite over hypotenuse, so that's going to be x over 3. And what we're looking for is cotangent theta, which we know as adjacent over opposite. We already have the opposite side, which is x. We just need the adjacent side. So in this case, if we sub in for Pythagorean theorem, we'll get x squared plus b squared is equal to 9. And so then we'll get b squared is equal to 9 minus x squared. And if we solve for b, we'll get b is equal to the square root of 9 minus x squared. So that's actually going to be the adjacent side of the triangle. And just to kind of give you a little bit of a visual as to what the triangle should look like, in this case, we're of course dealing with a right triangle. We know that the adjacent side, the hypotenuse is 3, the opposite side is x, and we now have the adjacent side, which is the square root of 9 minus x squared. And so now we have cotangent theta, and cotangent theta would just end up being the square root of 9 minus x squared all over x. So this is where we were at before we went to the next page. So remember, this is what we had after using a Pythagorean identity. We then went ahead and integrated. We got negative theta minus cotangent theta. So now all we have to do is plug everything back in. So this would give us minus arc sine, or sine to the negative first, of x over 3. This would be minus the square root of 9 minus x squared all over x, and then plus c, which would be the answer. So your final answer for this integral would be all of that right there. So we're asked to integrate the square root of 9 minus x squared all over x squared dx. So the answer again is going to be negative sine to the negative first, or negative arc sine of x over 3. And this is minus the square root of 9 minus x squared all over x. And again, don't forget about the plus c. And that's the solution. All right, so let me circle that for you. And that's your answer. So if you have any questions about how I arrived at this answer, please let me know. I'll be more than happy to explain further. But that's another quick example. All right, guys, I'll see y'all next time. Y'all take care.